Now we're ready to continue with section 12.2. So we went back to chapter 9 and finished a section, and now we'll go back to chapter 12. And we're going to be looking at some conditional probability. And here's a basic formula for conditional probability. And the idea is this: if I kind of show you a little Venn diagram of what's happening, let's say this is event A and this is event B. And if we want to find the probability of B happening, given that we know A already occurred, so B happening, given A already occurred, it's kind of like we look at this little Venn diagram circle. We know A occurred, and we want to find what part of A is B. So what we picture-wise do, this little component here is the intersection of A and B, or I could write the symbol A intersect B, is to calculate what the likelihood is of B happening given A already occurred, is we find the probability of the intersection, which is the probability of A and B, and then we divide it by the probability of A. Now sometimes we can do this by doing it in terms of a count. If we can actually, and I'm going to use N to stand for the number of elements, if we can find the number of ways that A can happen, and then the numerator is the number of ways that we have an intersection, sometimes this is a little bit easier to do. So it depends on the way the probability is given, and you'll see what I mean as we move to this first example. So we have two fair dice are rolled, and I want to find what's the probability of getting a sum of 6. So if we start out a sum of 6, we could write down all the different ways that it occurs. We know that a 6 can happen with a 1 and a 5, with a 2 and a 4, with a 3 and a 3, a 4 and a 2, and a 5 and a 1. So we have 5 ways out of 36 for that to happen. Now I want to find the probability that if I roll 2 dice, that the first die comes up a 2. And again, I have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And so there are 6 ways out of 36 for that to happen, or a 1/6 chance of that happen. Now, if I want to find the probability of the sum of the dice coming up a 6, and the first die is a 2, notice that this is all I have. That is the only roll that will work. I'm not going to do any fancy formula of multiplying anything together because I don't know if I have independence. So I just count literally how many work, and I have one roll that works, a roll of 2, 4. Now I want to find the probability of the sum being 6 or the first die comes up a 2. So we know that the likelihood that the sum is 6 is 5 out of 36. We already found that in A. We know what the probability is that the first die comes up a 2. Again, we already found that in letter B. However, if we just add these two together, we just double counted the 2, 4 roll. So we end up getting a probability of 10 out of 36, which is 5/18. Now let's look at a conditional probability. And in a conditional probability, I want to know what is the probability that the first die is a 2, given that I know a sum of the 2 dice is 6. So again, we could go back and use our probability formula and use the values that we got from our formula. However, we're going to look at it this way, with counting how many ways it can happen. You know the given condition took place. You know one of these 6 sums came up. You know one of these came up. Given that the sum is a sum of 6, how many of those have the first roll being a 2? And I can see all I have is this one. So I have 1 working out of 1, 2, 3, 4, 5. Now we can use this formula with all of its probabilities and all of its glory, and I wrote that up here, where we find the probability of the intersection, which again we already had found up in part C, and divide that by the probability of our given condition, which was 5 out of 36, and we're going to end up with the same answer. But if we can count and utilize this where we find the number of ways that our event can happen, and then put our numerator the number of ways in the intersection, it's going to be easier for us. And notice I did the same thing here. If I want to find what's the probability that the first die is even, given that the sum is 8, well, I would write down those sums of 8 first of all. I'd say a sum of 8, let's see, I can't have a 1. I can have a 2 with a 6, I can have a 3 with a 5, a 4 with a 4, a 5 with a 3, a 6 with a 2. And so those are all the ways I can have a sum of 8. So notice my denominator is 5. So I have the number of ways that this, slide this down, the number of ways that that event, the conditional event or the given event can take place. And now I'm going to count how many of those have the first die being even. Well, that one works, and that one works, and that one works. So my answer is 3 out of 5, 3/5. Now, I also could go through and find the intersection, which is 3 out of 36, divided by the probability of the sum of 8, which is 5 out of 36, to arrive at the same answer. But again, if I can count the number of items in the intersection out of the number of items in the conditional or the given set, that's usually the easiest way. Now I have a few examples down here that deal with this table, so sometimes we have table data. And in this case, we're looking at some different materials and whether they're recycled and whether they're not recycled. And I already totaled up the columns here, so I know the total amount of materials is 229.1 tons, and we know all the different itemized values. And on this first one, if I have my values given in a table form, we just want to see what we do as far as finding some probabilities. So find the probability that a sample is both recycled and plastic. So if I randomly looked at these 229.1 tons and I wanted to find what's the probability if I just randomly pulled out one sample, what would be the likelihood it's both recycled and plastic? I look for recycled plastic right there, and I have 1.4 tons out of a total of 229.1 tons. So I'd have about a 0.6% chance of that happening if I just randomly pulled out a sample. Number 3, find the probability that a sample is recycled or it's plastic. So it can be either one or the other, or it could be both. So I wrote my symbolism. Or means union. So I'm finding the likelihood of recycled, and I can see this whole column. I have 67.9 tons that are recycled out of 229.1. Then I have my plastic going across, adding these two columns together. I have 25.4 tons out of the 229.1. Now, I just double counted this material. If I counted it with recycling, I counted it with plastic, so I have to subtract it away. Now, number 4, let's look at a conditional probability. Find the probability that a sample of recycled waste was plastic. So this is a given condition. You know that the sample is recycled waste. So find the probability that a sample of recycled waste, that's my given, it's recycled, was plastic. So I know actually I don't have any of this non-recycled material. All I have is the recycled material. And so again, instead of, I could find this in terms of numbers, or I have it shown as my probability. I'm going to find the probability of both recycled and plastic. So I have this out of my total. And then my probability of recycled is just my recycled is the 67.9 out of the total. But easier yet is to go back to that, instead of finding the actual probability of these two events, just to find how much there is of each of these two. And so if I do this in terms of the number of recycled products is, that column total is 67.9, and the number of items that are in the intersection is 1.4, and that gives me my probability. And here, likewise, is another sample that's similar. Just you have to be careful about the wording of the question to see is it a conditional type problem or is it an intersection problem. Find the probability that a sample of non-recycled waste was plastic. So we know that the item was non-recycled. We'd only be using the last column. And so let's kind of go to this way. Here's my symbolic way of writing it. And I want to find the number of ways or the number of tons that are non-recycled. And that was 161.2 tons. And how many of those are both? And I find out by looking at my table that that's 24 tons. So this quotient ends up giving me that probability. Well, we'll continue in another video on the next part and then the next page. So that's it for this one.